Hi everyone, welcome to Deepu's Chemistry. In this session onwards, we are going to discuss some of the questions asked in previous CSIR UGC NET Chemical Sciences paper. And in this class, we are going to discuss questions from basic organic chemistry regarding aromaticity, stereochemistry and conformations. So coming to the first question, you are given three carbocations and you need to assign aromaticity into these compounds. How you can do this? Look at all the three compounds given there. In the third compound, you can easily say it's an aromatic compound because it has only 2 pi electrons. All the carbon are sp2 hybridized. So C is an aromatic compound, and we can easily say option is the right answer because in that option you have C is given as aromatic. All other options is given as homo, anti, everything like that. So we can easily say, or very easily say, it's an option A is the right answer. And here B, look at option B. It is an anti-aromatic compound because it has 4 pi electrons. So foreign pi system. So it's an anti-aromatic. And look at option A. It is a homoaromatic compound. Even if you don't know what is homoaromatic, you can say option is right. Because homoaromatic means it has an sp3 hybridized carbon here, but still it shows aromaticity because of the closeness of these two carbon atoms, this carbocation and the double bonded carbon, of which both are sp2 hybridized. So that is option A is the right answer. Now look at the next question. In the most stable conformation of trans 1 tertiary butyl 3 methyl cyclohexane, the substituents at C1 and C3 respectively are. So here you have a cyclohexane ring system given here, and in this cyclohexane ring system, the first position is occupied by tertiary butyl and the third position by methyl. And we know tertiary butyl group is a locking group. It is always locked in the equatorial position in the chair form. And in the options it is given as axial equatorial. So we can easily say it's a chair form in which tertiary butyl can only occupy equatorial position. So we can easily neglect option A and option D where it is given as axial. Now look at the third one. It's a methyl group and it is given as trans here. Trans means what is happening here? In the case of trans, if the tertiary butyl is equatorial and it is pointing upwards, the methyl will be going downwards. And methyl will be going downwards means it will be trans. Just like this. Look at this. In this compound, it is clearly seen here because here tertiary butyl group is what? Equatorial and methyl group is axial, and these two are trans with respect to each other. So we can easily say what? Tertiary butyl at equatorial and methyl group at axial. So here the option will be option C, right? Now coming to the next question. It's a match the following type question, and you are given three compounds and you need to associate it with chiral center, chiral axis, chiral plane, helical chirality. And when you are looking at the option here, and when you are looking at this option, you can easily say it's 3 2 4 4 3 2 2 3 4 2 3 2 3 4, something like that. Sorry, 2 4 3 and 2 3 4. So you can easily say it means option A or option 1, chiral center given here, is not applicable, right? Chiral center given here is not applicable. So here look at option A. Option A, it has a chiral axis passing through this chiral axis. So A will be associated with the 2. And B, it is clearly seen here, it's a plane. There is a plane here. So it will be, B will be chiral plane. So A2, B3. And which is the option given here? It's option D, which contains A2 and B3. And C will be 4. It's helical chirality. So option D is the right answer. Now coming to the next question, look at this. The Gaussian interaction values for methyl methyl, methyl Br and bromine bromine are given 3.3, 0.83. Among the following, the most stable conformation of 2,3 dibromobutane is. When you are given such values, a Gaussian interaction values, as the Gaussian interaction increases, the stability decreases. And here it is given that the methyl methyl value is the most 3.3, and then bromine bromine it is 3, methyl bromide it is very less 0.8. So you need to find the configuration or conformation in which methyl methyl eclipsing and bromine bromine eclipsing the least. Here look at the first one, there is methyl methyl eclipsing and bromine bromine eclipsing as well. So option A can't be the answer. Now coming to the next section, option B, we can have methyl methyl staggered, so no Gaussian, and bromine bromine staggered, so no Gaussian interactions here. And look at option C. Coming to option C, you have bromine bromine and methyl methyl interaction here, so it will be having higher energy. And coming to option D, you have methyl methyl anti, but bromine bromine is closest. So which one will be the most stable conformation? It will be option B, in which both the bromine atoms and the methyl groups will be anti with respect to each other. Now, looking at the next compound, it's the IUPAC name of the following compound is. How you can do this? First of all, you need to assign R and S configuration to this chiral center, and this chiral center means you need to assign whether it is R or S. First, then you can easily neglect two options, either it is R or it is S. So coming to this carbon, both are attached to CH2 group, so there is no difference here, CH2 CH2 CH2. Now coming to next group, here the carbon has 2 oxygen, or we will consider it 3 oxygen because it is double bonded, and here this carbon is attached to 3 carbons, triple bonded. Here the carbon is attached to 2 carbons, so it is, since it is double bonded, so you can say based on atomic number we can say COH, this one will give CH2 COH will be first priority, then comes alkyne part, and then comes the double bond part. So it will be rotation like this, anti-clockwise rotation, and since the lowest priority group is below the plane of the ring, we can say it is S configuration. So we can easily say option A and C are wrong. Now coming to this, which one is right answer? Because carboxylic acid group has the highest functional group precedence order, and we can say you need to select the longest chain containing carboxylic acid as number 1, and you have 2 functional groups here, double bond and triple bond, and out of this double bond has got a higher precedence over triple bond, so you need to select the main chain containing this carboxylic acid group and this C double bond C. So this will be our main chain, the double bonded carbon and COH, it will be our main chain, and this triple bond will be only a branch. And look at this 1 2 3, third position you have the triple bonded proper to YN YL, and you have hex 5 hex 6 carbon 1 2 3 4 5 6 hex in hex 5 enoic acid. So this is how you can answer. So option D is your right answer. Okay, now coming to next compound, look at this, some aromatic which you need to select some aromatic compounds from this list. Now look at the option C, it is naphthalene, and we all know it is aromatic, so option C is right, so we can easily neglect option B, that is A and B only. Now look at this first compound, it is 10-aniline, and we know 10-aniline is tub shaped. Tub shaped means it is not planar, so we can say A is not aromatic but C is aromatic. Based on this you can answer. You need to omit all the options containing A, so option A is cancelled, option B is cancelled, option D is also cancelled. So which are the aromatic compounds? Option B and option C. So that is option C is the right answer, B and C only. Now next one, you are given 3 compounds again, A, B, C, and you need to select which is optically active. And look at the first one, A. Here nitrogen has 4 different groups attached to it, so it is optically active. So option A is right, so option D can be neglected. Now coming to next one, this molecule has 2 chiral carbon atoms here. You can't say this chiral because you have a planar symmetry passing through here, right? So planar symmetry, if a compound has a planar symmetry, then it will be optically inactive. So we can say option B is optically inactive. So we can neglect which all options. A and B only can be neglected, B and C only can be neglected, A, B, C can be neglected. So which is the right answer? Option C, in which A and C are the right optical active compounds. Next question. Some diacids are given here and you need to find which one will give you anhydride the fastest with acetic anhydride. First of all, for anhydride formation, the reacting groups, carboxylic acid groups must be close to each other. And we can easily say option C is not happening, because option C we have carboxylic acid as far. So you can't have cyclization that easier. So option C is neglected. And now, coming to the next options, look at the option B and D. They are single bonded. So single bond means free rotation is always possible here. So free rotation possible means we can say you can't have a situation where carboxylic acid groups are close to each other. So you can say option B and D cannot be the answer. So option A will be the answer. Okay? So option A is the right answer. Now, look at this compound reaction. For the following two reactions, A and B, the correct statement is, which one is correct? For that, you should know the conformation. Here it is given as tertiary butyl group is same in both cases. You have bromine in the same plane as tertiary butyl group in both cases. But what is the difference is that here bromine and COH are cis, here bromine and COH are trans. We can answer this question without looking at the conformation, because this reagent, look at this reagent, it is given potassium tertiary butoxide, so it is given in excess here. So excess means you can say it is undergoing elimination. So eliminating groups, bromine will be eliminated and eliminating group should be anti-periplanar with respect to each other. So here you have a bromine here, and here the neighboring carbon has proton pointing downwards. So you can have easily H and B are getting eliminated, forming a double bond here. So this will be your A, COOK. Here this will be your A. But coming here, we have bromine and COH in the same plane. Opposite plane. And potassium tertiary butoxide, it's a bulky base. It can remove this proton, COH proton from here, which encourages the decarboxylation, forming the double bond between these two carbon, thereby eliminating this bromine as well. So in this option, we can have option B as the right answer. Here bromine and COH will be eliminated. Here only bromine and proton will get eliminated. So option B is your right answer. Now the last question in this session we are going to discuss here is, among the choices, the correct statement for A formed in the following reaction. Here you are given an epoxide and you are given a secondary amine, and it is going to undergo ring opening as shown in here. And since this reopening can take place either from top side or bottom side, that doesn't matter where this tertiary butyl group is given, because tertiary butyl group is far away from this. So there is no hindrance from the tertiary butyl group here, and since it is a cyclopentanone ring, so we can have NH approaching downside like this or upside like this. So we can say it can give both products, so it will be a racemic mixture. Now, so these are the questions that you have selected for this class. We will continue this for the further sections as well. So thank you for watching this video. Please subscribe my channel if you can. This is my first venture, so please support me.